Okay, we're going to try and do two lessons today. They're both fairly short. We're going to cut out a bit so the lesson goes quick and then you can jump right to the homework a bit more. Because I think more of this is about practice and making sure you're comfortable with the ideas than it is actual concepts we have to talk about. Anyway, let's get right into it. Example one. If you're given this floor plan, Maxine's moving to a new apartment and she jotted down the exact floor plan on a little sticky note, it looks like. And she has the actual measurements in here, so she's very thorough. She knows it's 10 feet across, 5 feet opening to the kitchen, 8 feet all the way to this wall, 9 feet long here, a little 2 by 2, a 4-foot opening to the balcony, blah, blah, blah. Now we're going to try and turn this into, this is a scale drawing, and we're going to try and use the scale drawing to place furniture in the room. She wants to she's a really big perfectionist. She wants to draw a perfect couch, love seat, and wall unit and have an idea of where it's going to fit in the apartment nicely. Um, Now we have inches in here, we have feet in here. We're going to have to fix that at some point. But the first thing we're going to need to do is figure out how to find what the scale is of this drawing. And I'm going to leave that to you guys, but we're going to talk about how to actually do that. So we're going to come back to these numbers. So let's go on to the next page. So how do we find the scale or scale factor of a diagram? Kind of three steps we have to do. Number one, we need to measure the diagram. And we need to measure the real life. Measure or know real life. The real life size of something. So we need to measurements of both. If we don't know both, then we cannot find out what the scale is. At least one of them. We need to know one length in the diagram and what it is in real life. If we know both of those things, then we need to set up, and we usually call it a K. So we'll call it the K value is the scale factor. And the scale factor is always what the diagram measurement is. And we usually start it as a fraction. Sometimes we can represent it a whole bunch of different ways, but we usually start as a fraction. Diagram over real life. So what is the diagram compared to real life? So if the diagram is bigger than real life, then it's going to be like 2 to 1. It's actually an enlargement. Oftentimes, I think far more often, the diagram is much smaller than real life, in which case it's probably going to be like 1 to 5 or 1 to 10. It's going to be different numbers, though. You're going to get some random numbers. And then what you need to do is you need to turn K into a 1 over a number. And how do you turn, if you have two numbers in here, let's say it's like 10 over 12, how do we turn it into 1 over a number? Well, we're going to divide by the numerator. Divide by the numerator on the top and divide by the numerator on the bottom. If we do that, we should get this actual scale, which is 1 to something. And that's what we actually like to see. We want to see 1 in the diagram is what in real life. And sometimes we can use different units here. So be careful. Stop. Be careful of units. We are going to have questions where we have to do conversions between different units. Including in this one, we already have feet and inches. So what's the scale diagram in your floor plan? I don't have a ruler on me, so I'm going to leave this for you guys to kind of finish this exercise. But I'll set it up for you. So you're going to do K equals. Okay, measure the diagram. First, we need something that's consistent. Maybe we'll use this 10-foot length right here. That one seems to be easy to measure, and it's supposed to be 10 feet in real life. So measure how long that one is, and put it at the top, and put your units. So I don't know what that is in real life. That's probably going to be like looks like around 6 centimeters or something like that. But anyway, give it a measure. And then on the bottom, it's going to be to 10 feet in real life. Roughly 6 centimeters in the diagram is something like 10 feet in real life. and then turn that into a unit measurement, into an actual scale, a unit measurement of the ratio. So divide both of them by whatever your centimeters was. And then you'll find 1 centimeter in the diagram is equal to something. Whatever that bottom is. So we can do it as a fraction, we can do it as a proportion, we can do it a whole bunch of different ways. What's the conversion for inches to feet? I actually have to Google that just to be sure. I needed the other way around actually. Feet to inches is 12. That's what I thought it was. Sometimes I think it's 16. Isn't ounces 16? I think ounces might be 16. Ounces to pounds. I forget though. But anyway, 1 foot is 12 inches. Now you have a choice. You can either do everything in terms of inches or you can do everything in terms of feet. I don't mind either way, and you can use decimals, but you got to pick one of those, and you either need to change what the scale diagram is into inches, or you need to change your measurements of these 3 pieces of furniture into feet. So do that, and then convert them. So I want you to write them down. So either change this to inches, or write down your measurements and change them to feet for your couch love scene wall unit, and then write down what they're going to be in the diagram. So you're going to actually multiply, I think. 1 centimeter is equal to 12 feet. So you're going to actually divide by whatever number you have here. You're going to take your measurement and divide by that. I probably should do one of these. I could do it. No, I don't want to mess this up because you're going to have your own measurements on here. So try and figure that out. If you can't figure that out, stay in the classroom and I can help you figure this out. Make sure we can get through that question. I'll do it with this one over here though. So do that. Take 5 minutes at least. Convert these things into how many centimeters they're going to be. And then place them in the diagram. Use your ruler and actually place them in the diagram. Okay, if you need to pause the video, please pause the video. I'm going to keep on talking though. Okay, if your diagram is a reduction, so this is just a really quick, you can look at scale factors in all sorts of different ways. If your diagram is a reduction, if your diagram is smaller than the original, then the fraction is going to be 1 over some kind of a number. Some number that's less than 1. It's going to be some kind of a fraction. As a decimal, it's going to be 0 point something. So if it's like 0.5, then it's a half a reduction. If it's 0.2, it's a 20% of the original size. 0.1 is 10% of the original size. So it's going to be 0 point something if it's a reduction. As a percent, it's going to be some number less than 100. 100% stands for the original number. So if it's 50%, then it's shrunk. 20%, 10% are all shrinks. The only thing that's enlargements are bigger than 100%. As a ratio, it's going to be 1 to some number that's larger than 1. Yeah, that's just the way. I think this makes common sense. You should be able to figure that out. And then it's the complete opposite if it's an enlargement. Sometimes you have enlargements. Oftentimes in science, you might get things that are really, really small in real life, and you want to enlarge them for the picture. So if you have an enlargement, your scale factor is going to be some kind of fraction that's bigger than 1. So k is equal to a number that's larger than 1. So it could be, we could give examples. I probably should have given examples. So in this one, it could have been like a half, or it could have been like a tenth the size. It could be 0.5, it could be 0.1, it could be 50%, it could be 10%, any of those kind of numbers. And it could be like 1 to 3 or 1 to 10. Any of those things would say that the scale diagram is much smaller. And all these we would call our k-value. And I don't mind seeing them anyway. Fractions are probably going to be the easiest for this lesson. So I would always say the k-value is a half, or k-value is 50%, or something like that. In this one, it's going to be larger than 1, so it could be like 2 or 5, or it could be 1,000 times bigger if you're talking about microscopic images. As a decimal, it's going to be something like 2.0 or 5.0. It's actually the same thing. Just turn the fractions into a decimal. It could be an actual decimal. It could be something like 7.5 times bigger than the original. As a percent, it could be 200%. 200% means it's double the size. It's not 3 times the size or whatever. It could be 250%. It could be any of these kind of things. You see percents often with photocopiers. Sometimes you make enlargements with photocopiers, and it wants to know what percent of the original size. So it might go 100% means the same size. 125% means you've made it 25% bigger. Things like that. And as a ratio, it's going to be something like 2 to 1 or 5 to 1 or anything. It could be much, much bigger. So all sorts of different scale factors. So let's try another one. It's actually the last question on this one. This is an image of an animal cell. The diameter of the animal cell is represented by the scale that is represented by the scale is actually 0.25 millimeters in real life. So it's 1/4 of a millimeter, which is pretty darn small. It's actually not that small. It almost seems like it would be visible. What's the scale factor used to draw this? So K is equal to diagram over real life. In the diagram, the diameter of this thing is 3.5 centimeters. Over in the real life, it is 0.25 millimeters. Now, these things are so close together, it's not completely necessary to make these the same unit, but it is often good. And in this one, they're close together, so we do want to do it. So we're actually going to convert the top one to millimeters. If you don't remember how to do that, I always think of it like this. I was showing Austin this on the board the other day. You go millimeters, no blank, centimeters, 1 blank, meters, 2 blanks, kilometers. So it always goes up by 1. It goes none, then 1, then 2. And every single step in this diagram is times 10. So this is 10 times bigger. To get from here to here is 100 times bigger. And to get to here is 1,000 times bigger. But for us, it's just times 10. So that should be 35 millimeters all over 0.25 millimeters. So what's the actual scale? We could do it really, really small. It might not make sense in this one because it is actually an enlargement. We might want to turn this one into the 1 this time for the scale factor. So to do that, you can either divide, just like we were going to do before, divide by 0.25, or you can times it by 4, if that makes sense. Which means 1 millimeter in real life is the same as 35 times 4. Which is 140 millimeters in the diagram. And then we can write this a whole bunch of different ways. We could say 140 millimeters in the diagram is the same as 1 millimeter in real life. So sometimes they say this is a sentence, diagram to real life is 140 to 1. So it's 140 times bigger. Good. This will take some practice. Make sure you check you did the coaches right. but definitely try a lot of these questions. That is a lot of questions. I don't mind if you skip some, especially if sometimes math teachers always overwhelm you guys with questions. This would probably take like an hour, and I don't really want to waste an hour on this. You can maybe try a couple more for homework. But what I'd want you to focus on is basically there's three ways to think of the homework. I should have told you guys this at the start of the year, but sometimes the 20-1s like to do all of them, so I didn't want to tell them that. If you really don't understand the concept, if it's very, very hard for you, like the radical stuff was, I would think of it like focused on the first half of it. Spend all your time, do all the first half of the questions, make sure you actually get your basic understanding down. If you feel pretty good with this concept, you think you get it, but it's still a bit rough and you want to practice, I would try probably doing like every other question. So if you're decent, maybe skip through, make sure you try try a little bit of the easy ones, try a little bit of the medium ones, and try a little bit of the hard ones. This hopefully is probably what you're going to do most often, because if you don't try the hard ones, then you might get surprised on the test. So that's probably the most common. And then the third option is you feel really good about this. You think this is an easy concept. You think 1 to 6 is really just going to be a waste of time. In which case, yeah, just go and jump right to the hard questions and do the second half. So I don't really expect you to try every question, but I do expect you to try like at least 6 questions. And based on what your confidence level is, one of those 3 options. Sorry, that should say 3. The third option, if you feel like you've got it mastered, I would kind of just look at the early questions, but then jump right to the hard ones and not waste your time. Okay, try these. I would actually pause here and I would give it at least 30, maybe 40 minutes and actually try these questions. And then we'll do the next video after that and I'll check in on you guys.